sin function, because before we just did something, right? I shouldn't show that. Okay, let's go to game 12, which is our project, and let's actually build it and see what we have. Next shell. GTI, maybe? Actually, we can do GTI, right? What did I have? Like make run? I have make run. Good, let's run it. Kind of forgot how this worked. Oh, okay, cool. So we have our grid, but as you can see, it kind of starts deviating up here as well. But that's not the real problem. The real problem is that we don't have size attribute. So if you look at the code for a grid, I guess. Oh, it's not a grid. That's some other size. That's not the right one. It's size X and size Y. We couldn't have size X and size Y because the blog post. We couldn't do this. So they talk about size here. Point hex corner. I, Y, I. What is I? Point hex corner. Oh, this is how they calculate the hex corners. This is actually what we want, this function. Sort of. So you almost can literally copy this over, except we need to make it, you know, be like Haskell. And then we'll get size. Okay, I'm thinking about it. Difficult. I need to put on my glasses. And I need to get some drink. Where are my glasses? Wait, I'll be right back. But yeah, I'm gonna use this function basically here. Because what we did before is do it by hand. I like their approach better because you just put in some point, like some point number, and then we'll just do like, you know, 0 to 6. We'll get the points out. Pi problem. It's slow though. Like they're using cosine, sine, angle, red, angle degree. I minus 30 degree. I divided 108 times angle degree. We need to pointy hex corner. What are you gonna put in? Center, which is a point presumably. Yeah. So we need to encode the v to c int, and then we'll put in my headphones so I don't get the annoying sounds. Cool. I'm not gonna play music anyway. Each corner is size, units away from center, encode. Size, which I presume I guess that's a double. And then finally we'll get the integer, and out comes a point. But this is actually not an integer. This should be corner. So this is a corner. Data corner is top point, top right point, bottom right point, bottom point, bottom left point, top left point, hex corner. So instead of putting an integer direct into here, we can pretend this is a number. I think we'll just map that to an int. 0 degrees, 30 degrees, 90 degrees. So you're actually starting with minus 30. If you put in 30, you'll get 0. So this is how you move it up. Bottom right. So you start out with bottom right, then bottom, then so you start out with bottom right point. That's 0. No. Top the 0th of the enum will be top right point, and the final one will be the top point. I'm thinking about how does this map to the enum, right? But we can do this explicit. Yeah, we should do this explicitly. Have to think of it. So let's just link to this as well. To int, corner to int, int. Yeah, we'll make this a vary, maybe double. Wow, it's fine. Can even make degrees out of this, right? 60 times I. So if you put in 0, you'll get 0 and you'll get minus 30. So the 0th one will be this position because that's minus 30. And then the first position will be here. Second position will be here. Third position will be here. So you start with top right point. That's what we call top right point here. We just gave it a label. That's what we did. So now I'm figuring out which if you use this formula. I guess we want to have degree. Corner to degree. But they are using maths for this. We can do this by hand. We can do this without any calculation to the power of pattern matching. Oh my god. Yeah, we can make it even more stupid. If we're using Haskell, we are masters of stupid code. I mean, you know, this is to the first dot you encounter with a space behind it. No. Let's just do, can I do like, you know, slash or equals? No? Slash or equals. Doesn't work, does it? Oh my god, I can't regex because I told to do the beginning of the line as well. Actually, I guess it's a little, yeah, I did this before. Come to think of it, this is wrong. I need to be after it. Can't program today. Oh, no. Yes. Good job. Okay. So, you know, we can just, you know, we can just say it. 30. Good job. You are 30. Bottom right point. You know, we can just write it like here. Top right point. Top right point. 330. 30. 90. Isn't this super obvious now? We don't even do any calculation. 150. 210. 270. You know, you could write down this, or you can pattern match. I feel this is a level of stupidity that's just beautiful. Center. What is the double then? That's the size. You get a center and you get a size. But I feel in hexagon settings we need to define the size. You should no longer be a v2 c int. You should be an int. We should fix our compile errors based on that size, which means maybe we want to put it into I don't think we want to put it into a new type. It just should be an integer. That's fine. Maybe an alias. Size. So my question is, do we want to keep that runtime configurable, or maybe we just want to define size at top level for now, not even make this a setting? I'll just keep it in a def, right? Def size 80. There we go. But this function doesn't care. So the thing about making this an enum, it allows us to do, for example, and we also want to make it bounded. With that in place, we can do top right blah, or we can do min bound, max bound, and this will give us the entire list of the enum. So this will make sure we get all the corners. Well, we have to also give it say what it is. So we, you know, can, for example, apply X corner to it or whatever. But this will give us the list of all the options in here. You know, it happens so often that you refactor your hexagons to have additional corners, but yeah, I don't know. And doing this pattern match forces it also helps us with refactors. Maybe we want to also make the, support for pentagons in our hex corner. Probably not, but this is super explicit, right? It's like, you know, top right point and you have an arrow pointing to the actual value. I don't think you can get any more explicit than this. I don't think at all. Let's copy over that code. I already did, maybe. Yeah, I did it here. Well, let's do the mathematics. Math. Blah, blah, blah. So, Santa. Probably want to coerce it, to be honest. Annoying. V2xy, right? Where was I? I lost it. Here. Okay. V2xy. This is the center. We want to make angle red out of degree. Where corner degree. Where degree is equal to blah. Corner. And we do red, which is pi. I don't know how you get pi in Haskell. Pi. No, it's from Prelude. It's just pi. Pi. Okay. Divided by 180 times degree. Degree. This is probably a double. This should be a double. So we convert the corner to degree to a double here. So now it's not like, you know, you have them in inch here, which is nice and all. But if you want to do this kind of stuff like division in pi, we need to make sure we get a degree double out. So if we keep this as an int, it's gonna kill all these operations. Because pi won't be any more precise if we keep it in int space. So we need to convert that first to floating point. Okay, and the result is actually I guess we want to make this just a double as well then. Just do that. Double. We probably also can find a but this is where plus size times cosine, which gets any floating point, red. That's x. Y plus size times sine, red. Actually, it's quite easy, come to think of it. I thought this the entire stream. We're just gonna make this, but I think we already did it. We just need to make a type check now, I guess. Oh right, I deleted all that shit. Yep. Size X, size Y. Vec tile, render tile. Yeah, all this stuff is broken now. Let's just comment this out. Oh, this is like completely useless. We can just delete it, I think. We need to refigure out the render function. Maybe make that error or whatever. But it's god damn it, it's not gonna work like this. Size X, size Y. We can just put in size, I guess. Right? Hexagon size. Oh, we're gonna define the position. To define a position, you also need to have the size. I guess we need to give size as an extra argument in here. Size. And it would work out. We're just gonna assign that size to the settings as well. This is what we rendered it with. Figure it out. Hexagon size is equal to size. Yeah, that makes sense because we don't know this one. We can make a default one, you know, but let's not do that in the rendering stuff. Could match expected type int with actual type double. We can fix that. It should be an int. No half sizes. We can't render halves. Could match type blah. width is 115. Right, this code. We actually need to rewrite this code anyway. And it's gonna be a bit more simple, I guess. Because, well, we can do that right now, I guess. I think this documentation should be here. The corners of the hexagon labeled. Okay, so we can trash most of this code now. I need to rewrite it. But that's what, like I said, right? We can start from min bound, max bound, and say we just want to have a list of corners. Yeah, let's trash all this code. Done. Go away. I'm feeling a bit like we're jumping into the deep, you know. But yes. We got the corners, so we want to have like a list of corners. All corners. Hex corner, and this is gonna be like min bound, max bound. Parse error. Oh, I forgot the equals. Yeah, it's not gonna be like that, man. So you know the center, so we can convert this just to points, I guess. And then we're done. We can use this function now. It actually becomes a lot cleaner, this rewrite. I think we can even do it directly in here. So we'll do pointy blah. We'll read settings. Center blah. Hexagon settings. Position. Size. I guess that's also part of the settings now, right? So we can read that out as well. And then we just fmap into all corners. So we partially apply point, integer, and then the hexagon keeps on changing per corner. And that's our code. So it actually becomes significantly more clean. I think it's even shorter. Better labeled. I didn't expect it to become easier, actually. Right, so now we need to... oh, that's a bit of a problem. Oh no, I don't want to become famous. Ban. Can I report him as well? Right, we need to tell them that they're C-ints. How do we do that again? I guess I can just floor all this stuff. So, you know, you do your calculation stuff. Integral floor. You're a C-int. The size is an integer, normal integer. Maybe I'll make that a C-int as well. I don't know. It's just like pointless conversions, right? With actual type double. Maybe that's the point. We should make this normal number, and then you can add it to whatever, because it's not going to change anymore based on that. It's important that this stuff is done without rounding, but then the plus doesn't matter anymore. It's not going to impact anything. Oh, I fucked up even more. What? From integral. Oh, you know what? You need to also be a fact thing. Put you into V2 again. Great. View hexagon settings. Hexagon size. Half size. Where's half size? Oh. I don't think this is used. I'll delete it. Render tile. Okay, that's fine. Hexagon size. Let's just make a default size. Default size. Now we can export this default size, so they can use that. Let's see. Okay, I think this will only be called in one place, so we can just, you know, apply it for now. not a big deal. Render tile. Match type. Tile with int. Match tile. Type with int. Render tile. Oh, it's the wrong way around maybe. Hexagon, render tile. Yeah, you are the wrong way around. How annoying. Let's fix you. You get a size first and then... Look at that. That looks a lot better. It's bigger. But it's also consistent. It's regular. It's a bit of overlap here, I don't know. But it doesn't look... this could just be rounding bullshit, to be honest. That actually does look a lot better. I can't believe any of this is working. I wonder why it cuts off here. Oh, it's because of the STL window, I guess. Doesn't play it all nicely with resizing at the moment. I wonder if we could fix that. It doesn't do any redraws either. Because it never gets any events to redraw. Weird. Okay. It's surprising that already works. Oh right, we didn't even finish this stuff. What did I use a size, right. We already know the size now. We just give it everywhere. Pretty cool. Use the blog post with sign and code to render the tiles. Okay. Now we can also make click detection, I guess. Pixel to hex. Then we can even make it so that we change the state once we click on one of these tiles. That'd be cool. But what do I want to do, you know? How do I get there? Like, I'll think once we have click detection, we actually can start making a game. We could did I delete the button? No, not yet. Good. Because I want to use it for a menu, I think. We'll start figuring out how to make a game. We'll render sprites or whatever in tiles. That's a good idea. This math is crazy. Oh, that's the other thing, right? So tactile size. I think we're gonna make size a global constant because I don't want to keep passing it around. It's annoying. So we'll make size be everywhere. And hexagon, you're no longer parsed. We'll just know size, and you know we can figure that out later. It's just size. We're also going to remove it from settings, by the way. Make it a bit simpler. I guess no zooming for us, but it should be super easy to refactor if we ever want to do that. Right, hexagon size. So 83, you can just put in size. Oh. 117, we can delete. You don't need to set it anymore. And size X. Right, you're just size. QR. Right, we got stuck on this one because we didn't have a consistent size before, but now we have. It's just 80. It's always 80. It's actually really easy to do this apparently. We got size for Q, and then we got size for R, and that's it, divided by size. Point Y from an integral Y. So we keep on doing this, right? We convert it to a floating point, and then we convert it back to an integer. Because the on-screen coordinates are actually integers. Like these are pixels, they're concrete points. So we do all our mathematics with these fractional numbers, get them really precise and whatever. And then they can become integers again. Oh right, they do that. It's for type. Make sure the type's right. At least in other languages, it's not necessary in Haskell because you can just figure it out, right? I guess they can't figure it out in this case. We need to add an annotation. So we do want to do that. Default size. I'll just go default size. Right. hexagon size is also no longer in scope. Everything becomes easier if we just hard code it. Okay. So how do we know this is right? We're gonna throw in a, well, I say that, but we had it working before, right? This would work if we also have a size. You know, we can make the size configurable in the render logic and then hard code it into the guest instead. So this module is like functional. Well, let's not over engineer it. This is fine. Yeah, I shouldn't over engineer. So let's detect a click in the guest. How do you even do that? STL reflex click. I bet there's like some event thing. That's cool. Guess nobody's watching either because I never stream on Saturday. Dear God. Mouse click. 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 Get mouse button event. Mouse button data. And we have to figure out based on mouse button data what you are, I guess. Mouse device. Event position. Amount of clicks. 1 for a single click. 2 for a double click. Mouse button. The button that was pressed and released. Okay. So, yes. Let us get the mouse button event. And then I want to select mouse button left. You're generic? You're a generic. So I can just CTR it. You totally can do that. Ooh, that's great. So you're also generic. How nice. Yeah, I guess so. How would you do that? Filter it, right? You need to preview it. Do you exist? And if you exist, then we do that. Left click is prison. Mouse button to unit. CT or button left. Okay, and then we'll make another one. I wonder if you have STL lenses somewhere. STL lenses. Maybe someone already STL lens. Oh, something else. It's unfortunate. Left click. So we got the left click event, and then we want to make a lens from mouse button event data. This is also punned. Why are you punning? So annoying. It's the first. Mouse button event button. Mouse buttons. Lens. I mean, yeah, they pun, but I use the pun everywhere as well. In fact, like most of my Haskell code is punned. Why would I start complaining about it right now, right? I'm just meaning that the type is the same name as the constructor. So you got the type here and you got the constructor here. And if it's the same name, totally confusing, totally confusing. But apparently it's also problematic for doing type level programming, because they should share the same namespace. I'm just realizing that now that's a problem. Not that anyone's gonna care. Now we can compose these and filter on that event. So let's look at reflex event. I think it implements filterable, but we can't know because we can click on it, which is kind of annoying. How did they do this again? You got these types, but they're like associated types, so we can't know what they are. So perhaps I should figure it out in the instance. What is the type of event? Well, we don't know either. This is something else. This is one sample. Okay. Oh, right. You don't know which are the instances. Yeah, this is one of the more annoying parts of reflex. Then you are some type, pure T. And you're pointing to the associated type, so we still don't know what you are. It's so weird. How would I figure this out? People using default as well. Always fantasy. Is this an ancient? No, it's not an ancient one. It's just default somewhere. Well, I guess you're an instant. Oh, you filter event. Filterable convenience functions. Map maybe. Like map maybe. What the fuck is map maybe? You are exporting filterable, aren't you? Oh well. I guess I just want to filter. Has law. So weird about this. So we'll just do has filter. Oh, filter has mouse buttons dot left click. And then we put in the mouse button event. Events is that. What are you gonna do when you get the event? What are you gonna do when you get the event? We're gonna render our tiles differently, I guess. So what is mouse button event? Can we add a type to you, or do we need to have scoped type variables? I guess once we got a click, we want to render differently or something. We want to update. Yes, at least. If you are left click, at least. Right clicks are ignored. So yeah, let's just collect the types and add a signature, because it's otherwise too confusing for me. Event T mouse button blah, and we also need to add scoped type variables. Beautiful. Yeah, I already did that. Let's bring them into scope. Oral tm dot. Oh. Well, there you go. Tm, right? Yeah, tm dot. Prism, you don't know about Prism, you don't know about, oh, you want to use data kinds, because... Why do we have undecidability? Fuck you. I want to have the undecidability. Fat chance we don't even need that, right? Let's just... God damn it. Did I copy that over everywhere? I bet you don't need any of this shit. Oh, fuck you. You need a template Haskell. Is this one of my projects? Like, don't you get like a lot of stuff for free? You still don't know about lens. You see, like I deleted all those language extensions and nothing even changed. Most of the time you don't. Oh, this is cast. Probably need a lot. But maybe we need less. Let's just delete everything and see what goes wrong. Well, I guess we need scope type variables and data kinds. I wish Dante would help me now, so I can't write this. You don't know about blah, you don't know about field, can apply expression T1, type applications. Well, maybe data kinds already pulls it in, I don't know. Import, I have generic lens, right? I probably have generic lens. Generic product sum. Just pull in everything. You don't need to. Cool. I don't have this. Well. Generic lens. Totally need that. It's super important. We can't use blah. Can't use. Well, it wouldn't make any sense, right? To use template Haskell for that. Why would I generate everything if I can just generate a one? Make HPack. Give me generic lens. I don't know what it all means, but yes, run again, please. Could you? Oh, it's working. What did we even do? I don't think we did anything. How did it run? Did we fix everything already? Yeah, I need to look at reflex to see how we can re-render stuff. Event Haskell. Blah 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 blah. So I need to hold, I think. Maybe that's an SDL thing. I don't know. I need you to update if you get a I guess it's like widget hold, but we don't have widgets because we are in SDL. So it would have like another name, right? You have some solution for this. We need to carefully study this. They probably have some solution. Or I need to look at the hold view. There we go. Oh, that was quick. Default solution from event blah. We get default solution is this. Yeah, so we get default solution this, and then we get another one with which is the other thing. So okay. Hold view, and then we put in the events at the end. No, we don't put it, like we pretend we fmap this function into the event with the data, and then it can also be side effectly, and then we'll move out the side effect in here. That's the entire pattern. So you have some side effect in here, and you get it out after you get the event. Okay, everyone understands. Super easy, right? Okay, maybe not super easy. It took me a while to figure out. It took me maybe a week to figure out, but yes, now it's super easy, for me at least. So what are we gonna do? We're gonna go to hexagon. We're gonna detect tile based on the event data in here. So we wanna make a function, selected tile, which goes from this to tile. And we're gonna figure that out right now, how to do that. Well, first of all, we don't need to have mouse buttons anymore, but we want to make another lens, I guess. Let's keep making lenses for this SDL thing. I'm gonna make a separate library soon. At this base at least. I don't want to, but we'll have reflex. I mean, it's just SDL, right? Or it's re-exported, I guess. We need to have this one. So that will be mouse buttons to that. Mouse position. I guess they like to have long labels. I don't like to have long labels. So that's the other thing we do. We cut down a bit on the enterprise level programming. Mouse button. Blah, 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 blah. They don't like to use modules, I guess. You know, they like to jam everything in one module, so they get like massive amounts of conflict. But we can use modules for namespaces. Because modules are for namespaces, right? That's the entire invention. You act like a little name in front of your names, and you can use short names. That's the idea. But alas, not everyone understands that basic idea. So we get the point out, which is strict, by the way, but it doesn't matter. That's fine. We can put it in there. So we're gonna view blah, and then we're gonna detect the tile blah. And we're gonna compose that, and it's a function. So, and then we wanna make this render thing, render with tile. We're gonna, I don't know, we're gonna do something. Maybe tile. I'm gonna put Q in here. You're gonna change based on having the tile or not, I guess. Hold view. I guess it swaps it out after getting the event and just keeps on displaying that one. I hope. Yeah, you will get another event to update that event. Render with tile. This function will display whatever tile is highlighted. So this is the side effective one, right? We're gonna put it into reflex blah. Tile. Oh, there it is. I like having buffers, but yeah, we don't have to use it right now. We're just gonna hold view, render with tile, nothing, and then we're gonna do events fmap this thing into that. Select the tile, and then we have a selected tile because we can always figure out a selected tile. So we also need to compose just. But we're still ignoring it. But I at least like to print it. Please print it. Lift I output string line. Perform event. I'm not sure if this is gonna work. I hope it's gonna work. Selecting tile blah. Oh, and the other thing we could do is quick check. I forgot about that. cool. You don't know about in32. Whoa, that sucks. Ah, you are in32. Kind of annoying. That's kind of some primitive Haskell data int. Okay, probably need to convert between the two, but it's fine. Well, I don't know. Maybe we can round floor. Maybe num have floor or integral have floor. Oh, 2 integer. If not, no. How much integer? We need to convert that floor. Damn it. Maybe that only works on fractionals. It only works on fractionals. I'll just Google this. Oh, that's obnoxious. Hello, Agafa, how are you doing? Welcome back. Perhaps I did intend to use rank n types, if you tell me so. Did I intend to use it? Oh no, I didn't intend to use this. Oh, that's really bad actually. We don't want to use any rank n types. I learned about rank n types, come to think of it. It has something to do with who can use these, because like this, it's determined by whoever uses this function. But if you put it inside here, it's this function can determine what these are. So it like flips if you put it inside the, oh, like we did before. Yeah, I don't know. Like if you could do it like this, it's inside. I just realized that it's still inside. So we want to move it here. Definitely. I fucked that up. Still. We just want to have like a normal function, you know, we don't want to do any rank n stuff. So these are about constraints and these are arguments. And I just confused them. But that's not right. Variable not in scope, detect tile. Oh, we didn't export it. There you go. Yeah. Oh, we're not in 2. Yeah, this is actually reflex inventing. Oh no, actually it's not. Yeah, it is actually reflex trying to make your M fit. So it'll invent a type signature that works for you. But that, yeah, in this case we just forgot to do. I just thought it like looked so nonsensical that it must be that. And it was. Now we throw away the argument. You don't know about void. Let's import control monad. How are you doing, by the way, Wakafa? Oh, we don't know about show tile. Grid. Just had some dinner. Ah, excellent. A late dinner. Or maybe you have a different time zone. So our click's doing something, but yeah, look at this. It's figuring out things. Cool. Okay, is this 3-3? It is 3-3. It knows. Oh my god. So these all should be 3-3. Yeah. What about this? 3-4. That doesn't seem right. 4-4-4-3. So it is not completely right. That's kind of unfortunate. 3-3. It doesn't do it quite correctly then. Maybe there's some kind of offset. Maybe it's because we are in a floating window. No, that seems really wrong actually. It's saying 1-2 now. 4-4. That's completely wrong. This is why we added the labels, by the way. Now we have a fighting chance to figure out. This is correct. This part it just looks banned or weird. Hey Sour, how are you doing? Welcome back. Yeah, so we have a size now basically in our game. Hexagon. We have a size. So I rewrote the rendering logic, and it turned out to be a lot cleaner by doing this rewrite. We still have a bunch of math in here, but are you doing any special or just small project to work with graphic library? It is a attempt to make a game that is fun. So this is not about technical thing, it's just me using the tools I know best to make a game that's fun. And I got a recent obsession with hexagons, as some of my as Sarah probably knows. So we used hexagons, but yeah, we're just going to this stage by stage. But the backend of this project is called SDL, which is an ancient graphic library, and it just allows you to draw lines basically. Hexagons are great, exactly. Hexagons are fantastic. But we're just going at, like, you know, struggle by struggle. Because we need to know where we are clicking, and we, as you can see, if we're clicking on 1,2, it's actually printing out some different number, which means we are doing something wrong. Something is going wrong. I don't know what. Seems right. That seems wrong. I don't know why. Maybe the labels are wrong. You know, you never know. I just played Perfect Vermin. It's very nice. What's Perfect Vermin? Unit test? Yeah, we want to quick check this. We can totally quick check this, by the way, because we have a sort of invariant here. We need to clean this up a bit, but if we have a point v2cint that goes to tile, and we have a tile that goes to point v2cint, they should be isomorphic, because for any tile that goes to these two functions, it shouldn't change, right? And for any point v2cint that goes to these two functions, they shouldn't change. So we can at least make that assertion. I think I'm gonna rewrite it to support that. What is 2? Why do we have 2? Oh, we are doing more maths in here, I think, than is necessary, maybe. The 15-minute game, that's very nice. Free and also. Are you telling me to play it now? I want to make a commit first. Add broken click detection. More like play it before ending the stream. Sure, we'll do that. I'll take a quick break now. Get something to drink because I'm thirsty. I'll be right back. That's good. Whew. It's good to practice to find the types in the where part of a function. I've not done it so far. I don't know. I like doing it. It's like, you know, you get all these constants out of your way. I like doing it because then I pin this down. Because these functions are all polymorphic. So, for example, if you look at from integral at Google. From integral. It's all a to b and whatever. It's like, you know, you never know what you're dealing with. So if you say, oh, this x is supposed to be an integer, then it can't like say the type error is here somewhere. It will do that. It will say the type error is somewhere else, even though it's supposed to be here. So that's why I do that. But if it's good practice, I don't know. We need to make a function like this. We have a function like this here. It's just a bit wrong. That's all. We need to make it a bit more right. So we get a tiles input. Detect point. Detect tile, detect point. God damn it. These are horrible names. Detect. Calculate, man. Tile. 2, seriously? Well, I guess it is 2. And then put it into a point, also known as P. Actually, you can coerce it. And then we can put this in there. Now we're gonna make it a quick check. See points isn't declared on 112. May have had ambiguity related to the inference. I probably had ambiguity. I have that a lot actually. I have a really bad experience with that as well, because reflex likes to use this M, and that just makes things really difficult sometimes. You know, the type errors get awful. You have some still? I had a good one before, like a big one. Big one you don't want to look at. Can I find it? Yeah, this one. This is a good one. And if you look at this, you're just thinking like, dude, what are you talking about, man? A to F, B to what? And this was just us missing a do statement. So in here we missed like do, and that caused it to figure out this kind of stuff. And it's just, yeah. It does say it's applied to 3 arguments, which is probably wrong. Oh, I didn't do it on line 112. I didn't do it, huh? Calc points. What's calc points do? Oh, it's already strongly typed. So this is not polymorphic function, but these from integral, they are polymorphic. So yeah, they are no bueno. Yeah, let's make a quick check, I guess. Of tests. Oh, sanity of our test setup. Cool. Let's actually not use this one. Let's rename this to tiles spec. Or hexagon spec, to be honest. Spec. Describe the sanity of our... No. Calculate... I don't know. Tile to point to tile. It should be isomorphic. And then we need quick check. So check Haskell. And we're also gonna look up the properties of iso. Yes. No, it's easy. It's easy. It's super easy. I guess we need to make a generators and whatever. Yeah, you're gonna learn right now, buddy. I'm sorry. Today's your day. The most important thing, we need to import the thing, and then there's also quick check hspec. No, that's a property thing, right? That's kind of annoying actually. So we're just gonna do it by hand then. Or actually tell us to do it like that. Okay, cool. Property sounds easy enough. Should be isomorphic. Well, what is the property of isomorphism? It means that if you're gonna detect tile should be isomorphic to point B to C end. If you're gonna put in a tile, let's see. And then you have the other property that V2, C and blah is isomorphic to tile. So we're gonna get a tile. Cool. So how would you define this thing, right? So you get a tile in. We're gonna detect a point, and then we're gonna detect the tile from the point. Other is equal to where, and then these two need to be equal to each other, right? Because they are isomorphic, so they didn't change. This is like applying it. That's the idea. That's our property. There you go. So let's do it the other way around, where we get iso point. Because we need to have both. I'm not sure if we got the instances for free. We probably need to make them. That's fine. They're quite easy to make as well. So point. We're gonna detect the tile, and then we're gonna detect the point. And we need to not forget about do. So, how was learning about quick check? It's very difficult, isn't it? probably should also do like the import. But this is it. So yeah, it's just gonna throw random shit at this, and then if any of these properties are false, the test will fail, and it will do it like 100 times. So yeah, you don't have to like do any test data, because it will do it for you. And that's it. I don't know what else to say about it. It's a quick check. It's boring, I guess. If you have a property, at least, like you almost never have them. But I don't have test. Nothing to be done for test. All unit tests are boring. Yes. Well, not nah. I had like a lot of fun at work to make our test suite go faster. It was like, I'm doing all this crazy shit. That's fun. But writing tests? Yeah. Like, at least I don't have to invent random values here. That's a nice thing about quick check. I just need to think in terms of properties. And then we need to fix our test as well. I bet this is gonna find something, because, you know, it's a strong property. So, okay, so like, okay, I'll tell a cool thing, right? So you look isomorphism. Maybe we'll add it like Haskell, and you get like this. They usually have these kind of things, right? And you can see it here, apply. So we apply G to F, and that has to be equal to ADB. But what we did is we basically took this and we copy pasted into here, right? It's almost the same, because this is our G, this is our F, and we're just applying it to tile to get something else out. And then we're gonna make sure they're equal to the input. So it's like the same as doing it. So if you ever see these kind of law things, you can usually make a property test out of it, which is a big deal. I think I mentioned this in the presentation as well, didn't I? You probably were there. You probably were. I think you were. Okay, don't worry about mistypes. The compiler will tell me about it. New test. Oh, I need to be found. It doesn't really matter right now. Yeah, so I mentioned that, right? That the I think I mentioned it from them. I never can find it like this. It's kind of annoying that Google doesn't really work that well for Haskell. This doesn't know how to index Google, I guess. But you get these kind of properties, and these again, it's super easy to quick check, because you just copy it over basically, make a property out of it like this. But like quick checking other things like business logic, a lot harder. It's a lot harder. Right, that's the first problem. It doesn't even want to look at the rest of the stuff before you fix your little module name error. It didn't even bother looking at this stuff. It just said like, okay, you can't figure even out your file name equal to module name. I'm not gonna look at any of that. That's crazy. The most basic thing, man. Let's format this. Stylish. Oh, I think I did Haskell stylish. Okay, cool. We need to import tile, which is called grid. It's the right name. We need to import point, which is from STL probably. Reflex STL, I guess. And we need to import integer types. That's okay. Permanent the scope tile, which is the misspell you mentioned, I suppose. The tactile, which is from hexagon. Okay. Variable scope detect point. Right, because we didn't export it. We didn't have to export it before now. And then property, we need to get it from quick check. Okay, so we'll just import this. Figuring out my little exports is the most annoying chore ever. No! You are test! Why don't you know about this? Quick check. Come on, new test, come on! Oh. No, okay. Make HBack. This is my own little shitty build setup. It shouldn't be similar to your own. Probably different. Like everyone makes their own shitty little build setups. They're all different. Ah, You don't know about arbitrary tiles, and you don't know about arbitrary point blah. Ha ha ha. Stack has templates for projects. Yeah, they're not great. Yeah, Cabal also has that. I think Cabal init does that. I think if you're beginning with Haskell, Stack is a really good choice, because you know, all of that Nick shit, it doesn't give you that much in the beginning. It probably will never give you much if you're just working on your own projects. Problem I have with Cabal is that the documentation is so shitty. It's awful. Why this are you versioned? But let's see. Maybe just Cabal init or something. Maybe not Cabal new? I don't know. I never used it. And I think you also got like a tool like Summoner that will summon projects for you. Well, that's interesting. Oh, you don't have arbitrary instances for that. What is an arbitrary instance? Oh, we need to provide a generator. Okay. No problem, man. I can do that. And we need to tell it how to shrink. But I think you can leave this empty. Immediate shrinks of a given value. Your data has no special invariants. You can enable shrinking by defining. But by defining shrink is equal to generic shrink. But by customizing the behavior of shrink, you can often get simpler counterexamples. Okay. So what should we need to provide them for tile, and we need to provide them for ISO point. Oh, I left the test. Hexagons back. Instance arbitrary tile where shrink is generic shrink and arbitrary for tile is just tile, because you're just like numbers, right? Tile, right? We call it grid. Okay. The first thing I'm gonna do is rename this module because this is annoying. Oh, it has a grid. Okay, maybe we're not gonna rename it then. Yeah, so you're just integer. Okay. And the same thing goes for point v2 blah. Point v2 cint where p.v2, and we can test. Oh, couldn't match type blah. Perhaps like that. No instance generic for tile. Well, I'm probably gonna derive it for you. It's not like we have choice, right? Oh no. Generic. Where's generic? So that's in Hexagon. Probably has it. Yeah, I don't know. Let's ask Google. GHC generic. It's this one, isn't it? You're not a oh, you're a class. Of course you're a class. That's what I'm importing all this time. I thought it was data for some reason. I never thought about it could be a class. That actually makes complete sense. How could you else derive it, right? Didn't I give a presentation about that the other day? Well, not about driving. Type defaults are bad. No instance for arbitrary v2 cint. I guess you also want to have arbitrary for this. Like this, and then you're just arbitrary. It's kind of ugly. Well, that was quick. So if you put in a tile, what do you get out? Didn't even get we didn't even get to test 2 basically. After 2 tests and 1 shrink. After 1 test and 1 shrink. We just put in a point v2. So what did it get out? I wonder what it get out. I'm not sure. Maybe we can ask for it. check expected versus actual. Assume reason variable contains some kind of test. Then both success, fail, invalid conditions and a string. Note that it's the result type defined in print test case. Oh, okay. Well, we learned something today about quick check, right? Print test case. Expected. Show tile. Actual. Order. Show order. Oh, maybe we can use printf instead. It's kind of a bit neater. I really like printf these days. Expected as actual. Now at least you can see what. I mean, it's not shorter at all. I think it's just neater. And this will be property. Print test case. Okay. Does it work? Oh, you don't know about printf, right? Text. This is in base, by the way, this function. Will this work? There we go. So we put in tile 0 R1 here. I guess we only have to do the other one then. Actual result. Don't need to double it, right? There we go. Oh, Gaffa is learning quick check. Together with me, by the way. So we put in so it's fuzzing it, right? And we're putting in a 1 and a 0, and it gets out a 0 and a 0. So something went wrong somewhere. We don't know where, but one of these functions is breaking it somehow. Let's also fix the other property first. Property. What did it say? Use counterexample instead. What the hell is... printf. Or print test case, right? It tells us to use counterexample instead. What does it mean? Oh, we can't quite see it. Print. Oh, it's given string to the counterexample if the property fails. Oh, okay, that's well, I guess it's a bit clearer. Orphan instance. Or wrap to type in a new type. We can't do neither of these things. I guess we can move this to like test orphans. Orphanage. What is it? Orphanage. And we're exporting nothing. Haskell style is perfect. There we go. Missing home modules. We'll fix that later. So you still got the warning about orphanages. We're gonna fix that right now. Language. No, it's GHC options. So this is like the idea that you put all your nasty little orphans into the same module somewhere. The problem is these are not project orphans. These are just for testing. So I'm making like a separate test module. A test orphanage. And if we ever need more arbitrary instances, we can just put them in here. Oh, I added a warning, right? Or maybe it's options GHC, come to think of it. I always confuse these two. Look at that, that's better. So in orphanage, we still need to delete printf, hpack, and hexagon. Hexagon, printf, and hpack. Oh, right. The Discord. Yeah, we should fix that bot actually as well. Maybe we'll do that tomorrow. We have a service, by the way, to deploy it on, so it can just keep on running forever. And we'll also like upgrade to the new version of Tsoding and get our channel history. And he should have like a migration, I think. Probably not gonna work, but we can try it. I think that's a good idea. The bot as a service, right? Just chuck all these services on that Hetzner machine. That's my idea. Also raster, for example. Yeah, it's redundant, but I want the instances. So this is the first time this except warning works. Shadows the existing binding. We should fix that. So that's point prime. Then okay. HPack. HPack, not HPack, but why are they so similar phonetically? I write everything basically phonetically, which makes it really hard for me to keep them apart. It's also a great way to get spell errors, by the way. You can't always figure it out based on phonetics. Cool. Now, how to fix this bug? So that seems really bad. Minus 139. Jesus Christ. Wait, is this always so bad? Yep. Just minus 139? It's like there some sheer clicking on 0.01 and you're making a tile out of it. Okay, yeah. And these are pixels, right? So our hexagons are 80 in size. So this would be one. Well, this may be inside one hexagon. We're not sure about that. It's like the top left corner of screen, right? 0, 1. And then this, so 160 is the max bound of 2 hexagons next to each other. So it's like, well, maybe one off on the x-axis. I wonder what happens. I bet. Let's quick check. Test to figure out what's rendering. We can trash this, by the way. Will this still you to be main? I had a realization that it doesn't really make sense to put it in a separate folder and just have that one file that does one thing. You know, it's a bit crazy. So instead, we put it in source tiers. Select. And then we use game 13. HPack, dear God. Wonder if it still runs, or maybe I've broke it now. Testing probably still works because it's not related at all. But running. New run. Oh boy, I don't want to do that. Well, let's just run. I guess you don't need to optimize, but yeah, you don't know about it, do you? The run command is for running a single executable at once. The target refers to game 13 and the test suite unit. So it does know about it, because there was no main module. Which is game 13? Maybe it's supposed to be called main. That's fine. Oh, I don't like this. Let's not do any of this. It's too much work. Yes, it's fine, it runs. There. Isn't it beautiful? Broken, buggy, but beautiful. Let's fix our code. I guess it should be quite easy to fix now, because we just like monk around with this code until the test pass. I'm actually thinking the detect tile code is correct, but the detect point code is potentially broken, because I remember a bit of tweaking going around with this detect point stuff. So let's just jump to the URL and see what they are doing, and then just cargo code, basically like a pro. Pixel to hex, hex to pixel. I want to use the square root of 3. Let's put this together. No, you can actually, I don't know, hide away in a little corner. Where are we? Rings, reflection. This website is completely broken now at this point. Yeah, it's we are completely cargo culting this article. It's like we're not even thinking about it, to be honest. So it's not even funny at this point. I guess we are clever with our little unit tests. You know, it's not like we are. But that's not even a unit test, to be honest. This is the unit test. Didn't I used to have a make file that was able to test? I don't have a test command. It's a attribution to my glorious make file. How about you do new test with like options that make it compile faster? Isn't that a great idea? GSC options 0. And now make test. I like how you always trash your entire cache if the options change. But yeah, we got it. Consistently keeps on finding it on like the first or second try. And it has to do 100 of these, by the way. Oh, 2 tests. It passes 2 here. Only 1 here. So let's see. Let's just look at the code, to be honest. No, we're pointy top. Oh, flat top. It just flips or something. Interesting. So let's see. We are multiplying size. Okay. And then we're doing that plus somewhere here. Square root of 3 tile Q. Square root of 3 tile. Okay, that looks exactly the same. I'm not complaining yet. From integral size 3 divided by 2 spelled out. From integral hex R. Nope, this all looks correct. So you can add more parentheses. Maybe that works. But I doubt it. No, it didn't work. Maybe this is wrong then. Could be. So let's go through it step by step. Again, I like to jam everything on one line apparently. Square root 3, which is this actually. Thank you. Divided by 3. I think division has precedence, right? But we never can be sure. From integral x minus 1 divided by 3 times from integral y. Again, precedence. Why is this colored, by the way? Oh, it's just a weird syntax thing. Okay. Divided by size. Oh, you need to divide by size and you need to multiply by size. You're rounding. You're not rounding. You are rounding, to be honest. Okay. 2 divided by 3. Maybe these are not floating points or something. I don't know. It does complain about type defaults. So maybe we should fix them. Man, looks so close now. Look at that. B2 actual result 0. Are you passing more tests? No, you're not passing more tests. You're still failing on the first one. Yeah, I don't know. Let's fix those warnings. Seems important, you know? So, you know, maybe we'll put 2 with words in here. Should fix that warning. 2 divided by 3. Compiler should, by the way, optimize it out. Can just calculate it. It does look like rounding error somehow, I think. I don't know. Maybe like a minus or plus is fucked up. It could be. That could be. It doesn't sound too bad. Still to pointy hex. QR. Well, the other fun thing, right? You could fuck this up. Let's label them. But I don't think we fucked that up either. So, oh, in hexagon we have name shadowing for size. What do you mean, name shadowing? Your name shadowing. We can probably just hide pointy hex corner. Oh, right. Size prime, because we have a global size, which which actually is the same as size. That's a different size. We'll fix more warnings, right? Maybe our code will work one day if we just fix all the warnings. Unlikely. After 3 tests and 2 strings. Oh my god, after 2 tests. We are passing more tests. Only 100 to go, or like 200, because we made it on both sides. I don't know. It's probably just floating point bullshit at this point. How did they make it pass? Dear god. Are you flipping Q and R somehow? That'd be funny, wouldn't it? I don't think so. Oh, Q, tile, R. Oh, here's our thought. No, that didn't help. Oh, 4 tests. Wow. Maybe that was wrong. I wonder, so let's see. This is from pixel to hex. In comes the pixel, out comes the hex. Detect tile. Let's go over it. Calculation actual coordinates float q to the integer hexo. Hex round. There's a function hex round. Rounding to the nearest hex. Oh, there's a function called hex round. We completely forgot about the function hex round. Yeah, maybe I should actually read the code or like the article instead of just looking at the code. Pixel to hex, hex to pixel. But you're not doing hex round. Why should the other one do? Oh, right, we don't care about that. Pointy hex to pixel. No hex round going on here. Pixel to hex. This calculation will give the frictional axial coordinates. Convert the fractional axial coordinates into integer axial coordinates. Hex round. Oh, axial to cube. What the hell? If x div is smaller than y div, x div. I thought you just trash it with floor, but they're not trashing it with floor at all. They're actually doing work. Absolute. Okay. They're actually rounding. Cube x, cube y, cube z. The simplest thing is to convert to cube coordinates. God damn it. Cube to axial. Axial to cube. X is q. Z is r. Y is minus x minus z. What? So we convert it to cube, then we round it, and then we convert it back. Which is we're just throwing away the y. So why don't we just modify this code to not do any of that y shit? Because we're throwing away the y anyway here. We get in the cube. Q is x. R is z. Y is nothing. We don't care about y. Oh yes, the easiest thing is to convert to cube. Or we just modify this code to be correct. So we'll do tile round. I guess it's more part of the grid, to be honest. Round. So what are we rounding? Float. Maybe double. Y is compared to x and z. In here? We can derive y. They are deriving y in here as well. So we can also do it in this function. Why should I make a separate function? I don't get it. Actually... Yeah, I'm seeing it on line 10. How do you even count that? I don't think it's that. But I'm saying in the round function, they are just figuring out y by doing minus x minus z, which is actually q and r. So if we just do, you know, minus q minus r, or minus r minus q, whatever, we also get a y. We don't need to convert to figure out this function. But he's like, oh no, you should just cargo cult it like this. Well, maybe I'm too clever, you know? Or like, I mean, not cargo culty enough. Like, too clever as in a bad way. Maybe I should just, you know, dogmatically follow this entire blog post. But we have a bug, so we have tests now, so we can be more creative, I guess. We're set free by our tests. Q, R. Okay. X is Q. Y is R. Oh, no, Z. My god. Let's not get confused here. Z is R. X is Q. Y is minus X minus Z. Okay. Figure that stuff out. Okay. Round. Yeah, but they're not actually rounding. They're reassigning to rounded variable. What does round do? What the fuck is round? Is this normal round or floor? You're not trashing it? Floating point cube coordinate, and we want to know which hex it should be in. This comes up with line drawing pixel hex. Converting floating point value to an integer is called rounding. So I call this algorithm. Sure. Even floating point cube coordinates. Well, no, you can't do this with floating points. But I'll give you the benefit of the doubt and say, yeah, sure. You can't do full equality with floating points. They have error margins. You have to deal with error margins. We reset the component with the largest. Oh, thank God for the sub, man. Wow. More cargo quality than just copy paste the code. We can't even copy paste the code because it's some. I don't even know which programming language this is. I think it's some kind of Lua, maybe JavaScript. It's also not JavaScript. I'm not sure. Thanks for the tier 2 sub. You'll get like one emoji. Looks like Python. It's not Python because this is function. As I got pointed out by Sour. It's something else. But then, like, you know, rounding can be done in several ways, and they're not really specific about that. I guess it just mean normal round, probably. Def X Y. Just do it. We have our tests. We shouldn't think too much about it. We got like 100 tests to deal with this stuff. Why would we be so concerned, right? I guess you can be doubles then. Yeah. I'll make tiles out of you yet. Okay, so you got Rx and then your original values, which is xdef div is ABS, which we have, maybe, on a game. Why do you have tests? Because it didn't work. So, well, it's not really test, it's quick check. So it's this stuff. It's like, do the most dumb thing ever, right? I'll put your tile into the deck point, and then I put it into the deck tile, and then I want to make sure it's still the same thing. So nothing funny happens inside of these two functions, because they should be ISO. And then we're just throwing random data in there. So it's like we're fuzzing it. We're fuzzing our calculation. Oh, good night, man. The gameplay. Oh, you're a game. Right. Perfect Furman, right? Actually, I should sleep as well soon. We'll finish this function and then I'll go to sleep as well. Thanks for watching, Sour. See you later. Take you too seriously. Oh, do we have ABS, by the way? Probably. Absolute. X or no. It's Rx minus X. What the fuck is this? Ry minus Y. Rz minus Z. Okay. If X div bigger than Y div and Y div bigger than X Z div. Wait, what? You're overriding yourself? I guess he doesn't mean R, but like some other variable, which will be put out, which we'll call tile. Because X is equal to we can just call it Q, to be honest. Q, right? X is equal to Q. Right, we can't name it Q at all. We just have it name it like this. Q is equal to le, and then R is equal to that. Okay, cool. Man, my space is getting smaller and smaller. So let's see. X is equal to Q, right? Yeah. X is equal to Q. Makes total sense. And then we're calculating Rx here, which is the actual result. So we're overriding it. If this shit is true, Rx is equal to that. So this conditional override. We don't need to care about Y. And it's also else. Dear God, that's complicated. Okay, so let me think about this. We can trash this assignment, but we cannot trash this condition. This condition still needs to become part of this, but in like reversed form. Okay. I guess we'll just make like conditions. Can't you just do the conditional in guards? They are overriding variables, so not quite. Because first condition, I don't know, is x div bigger than y div, and x div bigger than z div. So we can do this, right? If blah, then we actually do this. So it's ry minus rz else rx, I believe, which is q, right? If first, then you do that. And then if not first, I guess we'll make a custom condition then. This is q override, which is a boolean. And then we have R override, which is also a boolean. I'm not going to jam it in here because it'll become ugly. I'll jam it here, which is not Q override because it's an else if thing. And, oh, we don't use words in Haskell, remember? And so y div smaller equal than z div. And I'm doing it in like reverse logic because it's else. So if this is true, this condition is true, we're gonna do this. We're gonna do rx minus ry else rz, which is q. Z is q. Or z is r, I mean. And this is it. So we need to round q and r. Oh, I bet it's actually better if you do it like that. Just to put it in as arguments. Let's do that. Rather than wrapping everything inside. It's a bit cleaner. Ambiguous on current round. Oh, I called the function round. Right. So it's actually doing infinite recursion right now. Right. Round tile. It's called grid, it's not called tile. Couldn't match type int with actual type double. Okay, so these become integers, I guess. Z is an integer. And X is still... What? They have a type error in their code. So do I make this into a... I suppose because absolute... God damn it, how does absolute work? This makes an integer out of it, right? No, it just removes the sign. But then we just use this stuff for comparisons. I guess we want to go from integer to float. You are rounding, but you're making a integral out of it. Great. Couldn't match type int with double. Let's annotate all of these. And now we're assigning RZ and RX. So we actually want to have this as int. Can't make these ints without actually changing the code, so we need to make these floating points. And let's figure it out now. Yeah. Oh, we didn't save this one. Cool. Purple scope, round tile. It's the arg. I want to have a link to that as well, by the way. We're gonna lose where we get all this stuff from if we delete it. So conversions, which is the most shitty conversion ever. Then again, like all of this stuff must be obvious to that guy, whereas a lot of it is like really not so obvious to me. Maybe he's just like really thorough. And it didn't help anything. Oh, actually we've passed one of them. We fixed one of the entire, like one completely. The other one is still broken. But we fixed the point. Oh, I copied the names because I was too lazy. We actually fixed one of the tests by doing this. So there was a bug. We didn't read cautiously enough, and we fixed it by doing quick check stuff. And this is the first time I'm fixing something with quick check, like reliably. Well, the second time I think. I don't know. But yeah, it threw 100 tests at it. And they all pass now. They're FATs as well. Because they're all pure, right? There's no database access or whatever going on. So tiles should be isomorphic to point v2. And then this is point v2 should be isomorphic to tile. Yeah, so we're quite sure that the tile to point. What the fuck is the description? To pixel. Now I realize why people use vice versa. Out to pixel and vice versa. Point v2 here and should be isomorphic to tile. We're still failing that iso point one, which means detect tile and then detect point. But we are passing detect point, detect tile. What does this tell us? I'm not sure, but we're breaking it somehow. Weird. It feels off by one error, to be honest. How many do we pass? Oh, after one test and 2 strings. Well, it's actually one of the more obvious one then. You know, if we would fail like test 70, then I would be more confident. But yeah, I'm gonna quit streaming for today. Thanks for watching, everyone. Yeah, well, unit tests are great if you are not sure what you're doing, like I was. But I knew this should be similar. I even think if we run it now, it's like it's less broken already. You see, it's doing it mostly correctly. For maybe 1, yeah, it's like clicking it correctly. So we actually fixed the bug by doing this. But I'm concerned because the other one is still also failing, and I think the property should be same for both. So I'm not sure why the other one is failing, you know. Maybe it's rendered still incorrectly, or I don't know. It's weird, right? Because the only thing we're doing is we're flipping the argument, the initial argument, and that's why it's failing. But it could be that it's just like 1 pixel off or something. Something weird like that. I don't know. It looks like the click detection is working at least now. It's here. So detect tile is this function. We're putting in some random point and then we're getting out a tile. But if you go to detect point, then we're putting in some tile, which is here. And then we're getting out some point, right? The other point. And then we're simply just asserting these are equal. The other is equal to the point. That's our test. We're getting in some random input. We're going through this chain. So detect tile and then detect point. And then we want to make sure the result is the same. That's all we are doing. It's really, really basic stuff. But it's failing for some reason. Well, this is not basic at all, but this is a really basic property. That's what is good about this, right? Like it's common sense property, easy to understand, but we're still failing it. I think most people can agree that this should be the same. Yeah, because Okay, like in the game itself, we click somewhere, right? We click here. And this is actually a pixel coordinate, right, where we're clicking. So we want to go to some tile, which is what we're doing here, to some tile. But if we're drawing this on screen, the tech point, for example, the label, we're drawing it somewhere on screen. Then we have some tile in the grid, and we need to get the point out. So these need to be the same. Like they need to be the same way of thinking, I guess. That's why I make these properties. Because you want to click on the label, for example, you want to click, you know, well, you want to make sure you're clicking on the right one. But yeah, anyway, I'm going to quit. Thanks for watching, everyone. It was a good stream. I had fun. Probably stream soon again. Maybe tomorrow. Probably tomorrow. And we're going to do maybe. Or set up Sorting's chatbot. Yeah, thanks for watching. See you later. Thanks for the sub, by the way. Maybe just James. Bye. I want to commit first, by the way. Fix the tag point test.